All right, everybody, we're back here again for another spooky software episode. Today is a very exciting episode, something I've been wanting to talk about for a while. Today we're going to be talking about collaborative applications, soft real-time collaborative applications, and how you write them, in the browser or otherwise. And in particular, we're going to be talking about one technique called, a relatively newfangled technique called CRDTs. And we'll get into exactly what that means in a little bit. But, first I'm going to start with a demo, right? Which is, I've got this application here. You can see I've got Chrome here in the front, on the right, and then Firefox on the left and the back. And there's some collaboration here, right? So this is like a drawing application. Think something like, Figma or Google Draw or something. I can, move these things around. I can delete them. I can, do whatever. And I've got some sense of like who's online and some cursors and this kind of business, right? And, the question is like, how would I go about building something like this, right? That's what we're going to be talking about today. So, let's just take a sidestep and, we'll come back to this application in a minute. We'll just assume that it's good to go. But I just want to show this picture because clearly we've got some kind of like data replication going on here, right? So, each one of these circles you can think of as a computer. In my example application, I was using, both Firefox and Chrome. And, while it's the same computer, it's my laptop here, we can imagine that, they were actually two different computers, maybe distributed across the world somewhere. And they're sharing data. They've got these boxes, location, sizes, colors, all that kind of stuff. And the question is, somehow we have to share that data so that, we can draw HTML, we can draw these boxes in the browser, right? And so how do we do that? So generally speaking, this is like, this is actually a pretty general problem. Like, you might even hear about this in terms of like, database replication in the back end. Like, maybe you have like, leader servers and replicas and all kinds of stuff. That is actually the same problem. But today we're going to be talking about clients because CRDTs are typically they certainly can be used in the back end for like a lot of like analytic data or high performance kind of high availability aggregate systems or whatnot. But I think they're particularly applicable for clients, like data that people would interact with. And we'll kind of get into that why in a second. But generally speaking, there are kind of two kind of broad ways that you can replicate data, right? And so the first way is like some kind of like coordinated thing where, especially in the case of like database replication, this is often how it works, but not necessarily, where, like all of the replicas, all of the clients will somehow coordinate with each other, maybe through a central server or something, and like modifications will be allowed or maybe transformed in certain ways by this coordination, right? Unfortunately, the problem with this approach is, first of all, it requires this coordination. So it requires some, communication between these replicas at all times. If you're familiar with the CAP theorem, this is kind of where that consistency idea, these strongly consistent ideas come from, is that to have that, if you have a network partition, where like maybe one of these replicas goes offline temporarily or whatever, you basically can't make modifications to the data anymore because you can't synchronize and you can't like confirm things or whatever you need to do depending on your particular strategy, right? Now, the good news is like sometimes that's totally okay or whatever, and sometimes you really need that strong consistency and you should use it when you want to, but a lot of times you don't need it. And if you don't need it, you can get away with a lot of stuff. Like if each one of these replicas is sort of allowed to make transformations to the data at any time and just sort of optimistically assume that any problems that they have, any conflicts that they have can be later solved through some process, automatic or otherwise, you can get like all kinds of things. You can get, nice performance benefits where, not every operation has to be sort of confirmed necessarily. You can also of course, make your application sort of decentralized. You don't necessarily need, for instance, a central server And of course, it may be in clients, maybe you have mobile apps or something like this where, the user may temporarily or intermittently have bad networking or no networking at all. And so they can kind of keep, doing their thing, maybe a note-taking app or whatever offline. And then later when they like actually get a Wi-Fi connection or whatever, they can sort of synchronize, right? And actually, this is actually the approach that Git takes. I'd like to take a sidestep here and talk about Git, because Git does this too, where sort of everybody's computer has a copy of the Git repo, and you can make changes to these files, make commits, all that stuff, sort of with or without an internet connection. You don't need any confirmation from some authority or another developer to make changes to your files, and how Git does this is it's optimistic. It assumes that everything will work out in the end. And in the case that there is a conflict, Git asks the user to solve it in some kind of conflict resolution process. So in this example, we have two branches going along. This main branch and somebody's local copy of main branch. The data started as hello world, single line, and then concurrently. Somebody changed it to hello dog, and then somebody else changed it to hello cat. And, the question is, during this merge process, either through a rebase or a merge commit or whatever, a user steps in and says, okay, Git, I'll tell you what the answer is, right? And, there's like a manual process, right? And that works out great. And in the case of Git, that's probably the only real strategy you could take, because it's source code. And like this process, the integrity of the source code sort of needs to be determined by user. Git is not smart enough, especially for all programming languages, to automatically handle conflicts. So this works out great. Now, the question is like, is there a way we can sort of get nice decentralized data structures, nice decentralized architectures where, this person who's working here and this person who's working here can, in fact, not coordinate with a network connection or something else, but still not have to handle this conflict resolution here, like not have to sort of manually step in as a user and say like, this is the thing. It turns out, yeah, there is a way, and that's what today's video is all about, is these CRDTs, right? And so essentially, you can think of a CRDT, which stands for conflict-free replicated data type. You can think of it as like a data type. Like there are many of them, and they all kind of comes in different shapes or whatever. And for instance, in today's video, the application that we were looking at earlier, I'm using an implementation called Yjs. This is just sort of a very popular library for JavaScript, but it's an implementation of CRDTs, and it uses the algorithm that it uses is relatively refined and high performance and whatnot. So that's why I chose it here. So Yjs is basically all CRDT libraries, will look something like this, where they essentially provide you with, for example here, some APIs to use data types that look very similar to sort of normal data types. Like, for example, here's a map, but this is a CRDT map rather than, sort of a JavaScript built-in map or whatever. But the API that you use as a programmer, as a user, looks just like a map, right? You put a key and a value into the data type, etc. It also provides other data types, like, for example, let's look at share types. Here we go. Like the array data type, right? So this, again, should look very similar to sort of a normal array, although it's a CRDT array, where you have, setters for, indexes, and you can merge and you can delete items and stuff, just like you could with the normal array. But sort of underlying that data type is a CRDT algorithm. And we'll discuss exactly kind of what that looks like, not in exquisite detail, but at least sort of overarching ideas. We'll take a look at actually how this is implemented a little bit when we explore later. But the idea is that, it provides these data types for you. Like here's an example of a data type for text, right? This might be something you'd use for something like Google Docs or something like this, where, multiple users are editing a text box, all right? And so again, everybody's editing in this text box. Some people might go offline temporarily, might make changes, and then they later resynchronize. We want to be able to synchronize without any conflicts, right? We don't want that sort of user step-in moment where like, okay, I'll tell you what it's supposed to say, right? Because CRDTs are capable of, like basically by mathematical properties, they are capable of guaranteeing consistent state, and no matter which order of operations occurred or when people came on and offline, the concurrency ordering doesn't matter. At the end of the day, so we get this eventual consistency, if you will, that everybody sees the same text, everybody sees the same array or the same map, right? And so we can just take a look at that in code, actually. So if I come over here and I pull up my thing here, let's make this a little larger. So this is the application code, or part of the application code for this collaborative app we were looking at just a moment ago. But, I'm not going to go into every line of this application because it's, maybe only total 500 lines or something, and most of which is, drawing some HTML, handling click events and whatnot. I'm mostly going to focus here on sort of the state of the application, which is, just defined in this function here, which is, only like 60th lines of code. But you can see this looks very similar to like a centralized state store that you would have in a typical client application. The only real difference is the data types that we are manipulating, rather than being regular JavaScript arrays, they are like these CRDT arrays, these CRDT maps, instead of, for instance, regular JavaScript objects, right? And there is some additional code here. So these CRDT libraries not only provide you these data structures, but they may also provide you some like networking code to synchronize these CRDTs across the network. So in this collaborative application, I was using the WebRTC provider. This comes with this Yjs library, where essentially I'm saying, any data that was stored in this document, which is, these boxes and positions and sizes and whatnot, I want you to synchronize with anybody who's connected to this, WebRTC room, if you will. And so in this case, my application doesn't have a central server. All of the clients, in my case, Chrome and Firefox, are actually just connecting directly to each other and synchronizing that way over a WebRTC connection. Additionally, I'm also persisting all of that data to the client's local database, like local storage. In this case, we were using IndexedDB. If you don't know what IndexedDB is, we're not going to talk about it at all in this video. But the general idea is that there's a database inside browsers called IndexedDB. Provides like a key value type interface. Again, this is just a provider that the Yjs library has, where I can, take that CRDT database or CRDT data structures and synchronize it in this database, giving me offline support. And so again, really, this is very straightforward code. We're just creating these CRDT data structures, and then in my event handlers, where I'm mutating state, I'm just using the CRDT API, right? I'm deleting boxes. Here I'm moving boxes, resizing boxes, and this is like, very, very straightforward code that you would see even if you weren't using CRDTs. If you were using regular, maps and arrays, it would look very similar to this. So, in just, basically 90 lines of code, plus some HTML and some event handlers and whatever, I've suddenly got this like highly collaborative app that requires no central server and does automatic conflict resolution, right? And so we'll demonstrate that right now. So if I come back here to my browser here, so again, I've got this, this collaboration app where Chrome and Firefox can communicate. Right now they're communicating over WebRTC, but I'm going to demonstrate something here. So I'm going to create some new data or whatever. I'm actually over here in Chrome. I'm going to switch my network to offline. So this is going to simulate that I don't have a network connection. And I'm actually going to refresh the browser because I already established my WebRTC connection. So this offline, this has to do with the dev tools, doesn't kill that connection. So even right now, I'm still actually collaborating. As you can see, it's synchronizing across these two screens. So I'm going to refresh. And even though I'm offline, you see that I got all this stuff. And that's because... let me just quickly log in here. And that's because this application has offline support. So over here in application, you can see that inside this IndexedDB, there's this database, syn IndexedDB, and it's got a bunch of updates in here. And this is kind of what I was talking about earlier, where these CRDTs are under the sheets, even though the interface that they give us looks like an array or whatever, they actually sort of are modeled as like almost like a log of updates. And so again, we don't have to go into the exact details of what each one of these records means in the database, but each one of these probably correlates to a single modification that I made. So for instance, if I moved one of these boxes to the left 10 pixels, maybe there's one record in here that sort of describes that. And so when we synchronize, these CRDT data types are actually synchronizing these quote unquote updates. And again, the property that CRDTs have, the algorithm that sort of mashes these updates together, just like Git mashes, commits together to create branches, is conflict free and is guaranteed that, sort of at the end of the day, after everybody gets all the same updates, they will see the same thing, right? So, so here I am over here on the right, and you can see that this is no longer replicated on the left. I'm creating some data types, I'm moving some things around, and then as soon as I go back online, like as soon as this network connection is reestablished, everybody synchronizes. And I can even go a step further. So again, I'm going to go offline again. I'm going to refresh so that all of my updates are no longer synchronized yet. And I'm going to move one of these. I'm going to move this top left one here over into the corner. And then simultaneously over here in Firefox, remember, these two things are not replicating to each other yet because the Chrome on the right is offline. I'm actually going to take the same box and I'm going to move it like, I don't know, down here, right? And so again, if I come back here, these are not the same picture. This box down here in Firefox is actually this one up here in Chrome. And the question is, when this guy comes back online, what should the picture see? And in the case of something like Figma or Google Docs or whatever, there are a variety of pictures that may be correct, but what's probably the most important property is actually that we all see the same picture, right? And again, so I'm just going to go ahead and reconnect. And as soon as I do, these data, I just clicked there. These data types using this CRDT algorithm synchronize, and everybody sees the same consistent state. And again, I didn't, as a user, have to tell this application, for this box, I really meant, it should be the top left or whatever. Now that we're synchronized or whatever, I can actually just move it back to the left because, that's actually the place I wanted it. That was my sort of conflict resolution there. Okay, so as we've seen here in this application, we use CRDTs to create this like pretty amazing sort of real-time, soft real-time collaborative application with automatic conflict resolution. And this works great with offline apps. It probably also works really well in sort of privacy or like security-sensitive applications where you don't necessarily want a central server. Remember, in this particular application, there is no central server. This localhost 43, whatever, is just, it's a stateless server just, serving HTML and JavaScript. There's no state on that server. All of the state is local in, the JavaScript virtual machine of each of these browsers and also replicated to this IndexedDB. And so I have a sort of decentralized server or decentralized application architecture where all of these things are like private and local, right? This is great for, stuff like Figma or Google Docs or, Google Draw or, anything like this. And depending on which CRDT library you choose, it may provide data types that work for your particular application or not. So this is all I really wanted to show you. I hope that you enjoyed. I will, of course, link the source code to this application, just in a public GitHub repo as usual. You can take a look at the source code. It's, in terms of user code, it's, very simple. There's, not a lot, because of all of the work that these CRDT data structures do for us, right? Well, thanks for watching. I hope you have a great day.